Welcome back. We're continuing to talk about relations and functions, in particular functions. In this video, we are going to look at function notation. Throughout Algebra 2, we will be using function notation to represent an equation that is a function. The basic premise of function notation is that instead of using y, we are going to replace y with f of x. Now, this isn't f times x, this is f of x. The purpose of this, f of x is our output and x is our input. So x's will be our domain and f of x's will be our range. We can write these ordered pairs for our function. All of our ordered pairs can be written as x, f of x. What this is going to do is it's going to help us keep straight when we have an equation and we solve it for a particular value of x. We don't end up with a bunch of y's, we end up with y values that are related to an x value. Because Algebra 2 is all about making true statements, but there are a lot of true statements we can make for an equation. So here's an example where I had an equation, y is equal to 5x minus 1. If I want to express this in function notation, I simply replace y with f of x. So my new function can be written as f of x is equal to 5x minus 1. This way, when I want to solve for a specific value of x, like I want to know what's y when x is equal to negative 6, or what is the paired value of y that goes with an x value of negative 6 to make a true statement. What ends up happening here, if I want to solve for y when x is equal to negative 6, I simply replace x in my function notation with negative 6, and then I replace x everywhere on the right-hand side with negative 6 as well. So negative 6, this is f of negative 6, is equal to 5 times negative 6 minus 1. And if I simplify this, I get negative 31. So this is the ordered pair negative 6, negative 31. Or another way of writing this, f of negative 6 is equal to negative 31. This is the x and y value that are paired to make a true statement. So looking at function notation. So if I'm looking at function notation, let's go through an example of how function notation is going to work. Given f of x is equal to 2x squared minus 8, find each value. Whatever is inside here will be my new value of x. So everywhere x appears in my function, I'm going to replace it with 3. The way I often like to work through these is I will replace x in my function with parentheses. Then I'll go back through and fill those parentheses with whatever is here. So this is 2 times 3 squared minus 8. I now work through my order of operations. 3 squared is 9. So this is 2 times 9 minus 8. 2 times 9 is 18. Minus 8 is 10. So f of 3 is equal to 10, or I can write this as an ordered pair, 3, 10. Both of these indicate that for an x value of 3, a y value of 10 will make a true statement. If I replace x with 2y, I'm again going to, everywhere that there was an x in my function, replace it with parentheses. Inside those parentheses, I'm going to put 2y. So even if what's my input has a variable, I just put it in where x was. Both 2 and y are being squared, so this will become 4y squared minus 8. This is 8y squared minus 8. So f of 2y is equal to 8y squared minus 8. If my function given is g of x is equal to x squared minus 2x, find each value. In this case, x appears on the right-hand side more than once. So if I'm finding g of 4, I'm going to replace x with my parentheses everywhere it appears, and then fill that in with 4. 4 squared is 16. 2 times 4 is 8. 16 minus 8 is 8. So g of 4 is equal to 8. This means that if I plug in an x value of 4, a y value of 8 will make a true statement, or the ordered pair for 8. With g of 3a, again, I put parentheses everywhere there was an x in my function, and I replace it with 3a. Both 3 and a are being squared, so this is 9a squared minus 6a. There is no further simplification I can do, so g of 3a is equal to 9a squared minus 6a.